Okay, this is video 2 for reassessment number 8 on work and potential energy. What we have is we have a cart, and we want to know the velocity of the cart at the bottom of the hill. What we know is we know that the height of the hill is 40 meters. We know that we are starting in the y direction. We're starting 40 meters up, and that we're going to end up at a final y value of 0. Because we started at rest, we know that the kinetic energy is 0, and what we're going to look for is we're going to solve for v in order to find, we're going to look at our final kinetic energy to find the final velocity. So what we have is we set our kinetic energy initial plus the initial gravitational potential energy equals the final kinetic energy minus the final gravitational kinetic potential energy. And we can further write this out as 1/2 mv initial squared plus mgy initial equals 1/2 mv final squared plus mgy final. We know that we start initial kinetic energy of 0, so we can go ahead and cancel that out. And we know that at the end our y final is 0, so we can cancel that out. So we end up getting mgy equals to 1/2 mass times volume velocity squared. What we're doing is we are solving for our velocity, so we can take the square root and we get the final velocity equals the square root of 2gy initial, and we plug in our values to where velocity final is the square root of 2 times 9.8 times 40, which is the height, and we get a final velocity of 28 meters per second squared. The second part of this question is we want to know at what height the car will have half of the speed. And so we know that we are looking for a final speed of 14 meters per second, still an initial speed of 0. We're still using the initial height as 40, but we're looking for y final. What height will the car reach 14 meters per second? So we pretty much do the same thing, set our equations equal to each other, and what we get is y2, our final y value, is equal to the initial y value minus the velocity squared over 2g. We plug that in, and y2 is 40 minus 14 squared over 2 times 9.8. This value right here comes out to be 30, so it's going to, it comes out to be 10. So it finally is 40 minus 10, in which the car will reach a velocity of 14 meters per second at a height of 30 meters. Like I said, this is my second video for assessment number 8 on work and potential energy.